A very good evening and a warm welcome to today's boot camp on basics of augmented reality. Build your own face filters for Instagram and Snapchat. I am Pooja Agrawal and I am a senior developer advocate with OpenWeaver. OpenWeaver is a SaaS technology company supporting over a million developers build their ideas faster by reusing open source software. Our vision is to reinvent digital realization. Simply put, improve the way applications are built. By investing in a unique combination of public domain knowledge and artificial intelligence, OpenWeaver is delivering smarter ways to build the digital world of tomorrow. Today's bootcamp is an integral part of our OpenWeaver community initiatives. The OpenWeaver community is a body of like minded tech enthusiasts and open source contributors who have come together with the vision of contributing to the world of open source and sharing how complex use cases can be developed by reusing open source. Over the last few weeks, we have run several open source development bootcamps on a variety of topics such as build your own virtual agent, build your own model for fake news detection, build your model for breast cancer prediction, another model for augmented AR powered e-commerce site, and many more to come. Today's bootcamp will cover the basics of augmented reality while focusing on an interesting use case where we will try to build face filters. Through today's bootcamp, you will realize that technology doesn't need to be complex and doesn't need to be developed in silos. You will see how you can take a solution that is pre built, in fact, pre built by many people in the world, and then you can build on top of it and share it or put it back such that your solution can now be accessible to many people who can further build on top of your ideas, thereby accelerating the virtuous cycle of innovation and helping you scale your ideas and solutions significantly. With that brief introduction of today's agenda, with that brief introduction, let's get to the agenda for the day. So, we will discuss a brief on what augmented reality is. We will also understand virtual reality and a bit on metaverse. So, as we'll talk about these different aspects or these different niche technologies, we will also understand the technology behind face filters and do an interesting snippet exercise, a simple coding exercise that will help you develop, or I would say that will help you also create a very simple code for yourself. But before we go ahead and discuss these concepts in detail, I would like you to set up the kit for today. So, to set the kit up, you will have to get onto the community platform that you are currently viewing the session on. So, on this OpenWeaver community page, you will see that there is a resources section, and under this resources section, we have the Candy One Click Kit. Go ahead and click on the Candy One Click Kit button. This will take you to a kit page. So this is the kit. This is the kit that we are going to demo today, or this is your face filters that we are going to build with the three.js library in JavaScript today. So just simply go ahead and click on the one-click installer. You can find the deployment information here if you would like to set on other operating systems. So we'll click on one-click installer, say show in folder, extract the contents of this folder. And as we extract this folder, it's very important that you extract this folder before going ahead and double clicking this batch file. Say more info, run anyway. This will start the process of setting all the resources, dependencies, everything onto your operating system directly. So let this setup happen for you. It will take around 6 to 7 minutes depending on the bandwidth that you are on. So let this happen on your systems. In the meanwhile, we'll discuss the concepts in detail. Also, I would like you to get an idea of what exactly are we going to discuss today. So this is one of the filters that is what we are going to go ahead and build and try to understand how this filter can be built. Also, the platform where you are seeing the session today, which is our community platform, important thing to note, apart from the Candy kit, you will also do a snippet coding exercise with me. You have an option to answer our interesting polling questions that are there on the platform. So as you view this session, you can go ahead and answer these questions. You can have a check as to what the other people are also voting for. And also you can join the community, post in your queries using the reply option that is available. So since I am also not logged in, I cannot see an option to reply on the platform. But yes, you can very well play around with these polling questions. Okay, so coming back to today's concepts and the building of this face filter, we would briefly want to talk a bit and we want to compare a bit on augmented reality, virtual reality, and metaverse. So, we pretty much understand that augmented reality is one of the niche technology areas wherein we see that different virtual objects are showcased, or I would say they are placed into a real world. And when we talk about virtual reality, it is we who get into the virtual world ourselves. So, important thing to note, between when we compare AR and VR, virtual reality is when you are putting yourself into a virtual environment. Let's say you're having a tea party with the CEOs of different organizations, or let's say if you guys have watched the Matrix movie, you know, you see that people used to get into a virtual world, fight with different people and all of that, and just then get back to reality. So that was a virtual reality experience. Or in fact, when you use a head mounted gear and get into another world and try and experience different digital experiences, that is a virtual reality experience. But augmented reality tries to connect the virtual objects with the real world. The placement happens in the real world itself. So if you see, I am on a virtual background. So this background over which I have been placed is some sort of an augmented reality experience, wherein the virtual background is able to capture the real person, that is me, and then want to build something which is able to locate my face and put the filter on the face. Currently we are going to talk about something like that today. But then this term metaverse has been pretty popular for a while. So, what is this term when we say metaverse? How is it different? It is a complete, again, it is a complete open, shared, and persistent virtual world wherein we are saying you are getting access to 3D virtual spaces, as in you can be the biggest blockchain owner in that particular metaverse. You could be anything when you are part of the metaverse, depending on the number of environment, I mean the kind of space that you have earned yourself by getting into the metaverse. So it's somehow built based on the concepts of virtual reality and augmented reality. But then the entire world, as you see, people are having these headgears, working around with these digital screens, viewing other people on the digital screens, viewing and discussing with other people on the virtual space completely is what metaverse is all about. Talking about like we want to focus on today's today's concept, where we want to talk about augmented reality. We want to talk about how these face filters are built. So interesting thing is, you don't need to download an app to experience your AR, right? Today, if you say these face filters, okay, you have already worked around Instagram and Snapchat, where you install these apps, you place them, you just focus them onto your face, and then those different filters start getting themselves placed onto the different surface, or I would say on the eyes, nose, or head, or complete face. So because how this has happened that you don't need an app. Today we are going to work around with a web AR, which is a uh, browser based experience, wherein your own browsers are smart enough, your smartphone browsers are smart enough, your laptop browsers have inbuilt WebGL or graphics for the web, wherein you are able to get yourself into an immersive, wholesome experience with AR and 3D versus 2D and flat UI. So nowadays you are able to develop 3D models which with the help of augmented reality are able to give you pretty much more than what you were seeing before. So when you talk about Previously, when we were using with smartphones and processors, there has been an increase in the scale. There has been increase in how you experience augmented reality, but web-based augmented reality has been something very very interesting that has come into the world today. So you use canvas and use that canva to display the different graphics and on the web. How do we do it? We use the web graphics library WebGL, which is wherein you place a video, you place a augmented reality object on top of a video or an animation, game, graphics, digital data visualization, photo manipulation. All of that happens real time within the video. Even as of now, you see the background. So somewhere this is also a web AR experience that you're seeing as of now. What these AR web graphics library do, it does a continuous sensing, continuous capturing and tracking of the environment. If I move here, the augmented reality, or I mean say the virtual background should be should be able to be set in a way that wherever I move, at least my frame should be clearly visible. Okay, so there is a continuous capture and tracking that is happening based on the position, right? It should not emit any of my person's hand or head or any other component. So even this is something that you're currently viewing me on a virtual background is a AR experience or a web graphics engine experience that we are continuously being tagged with. To give you a little gist on the types of tracking, you have your marker based AR and you have your markerless based AR. So when we say that the virtual objects appear on top of a target image, like you have your barcode images, you see that nowadays when you are ordering food and you are going for these menu, you are able to simply scan them, and you may also, rare places you're actually getting to specific places where you'll be able to get the menu popped up, and in fact from your cards that are used, you may have your business cards or for your product marketing invitation cards, where you see the graphic, somehow the 3D graphic looks, I mean the experience looks 3D. The experience looked a little, I would say, popped out from the 2D sphere. So all that type, even there is this um, furniture app that uses marker as well as both markerless. So when we are saying marker based experience, what happens in the marker based? You are giving the device, the scanning engine or the capturing or the continuous scanning engine, a marker. That marker is fixed. Wherever that marker will go, there the sensing or there the augmented reality object will be placed. Okay, but when we say for face tracking especially, these face tracking ears are markerless based usually. Reason being, these are attached to object, to human faces. All these Facebook and Instagram filters, these are markerless based augmented reality experiences. These are used in marketing campaigns. You have virtual try-ons for lipsticks, for cosmetics, for clothes, which are being marketed by Mintra to all these interesting cosmetic websites like Sugar, etc. So they are using markerless. There is a niche area, or there's a niche marketing, uh, products, or I would say companies which are using augmented reality to market their products. So talking about the world tracking AR, which is again markerless. So then here what happens? Objects are attached to a ground, wherein I was saying about a IKEA app. You want to check if a particular furniture will fit well into your house. Okay. So when we say world tracking AR in the markerless form, it is not restricted to a particular face or image or physical object. It is about the entire world that is being scanned, and then objects are placed based on, say, a particular area, ground, wherever you are trying to scan that particular area with your device, or let's say your camera. So important in augmented reality are three components. We'll talk about that as well: camera, scene, and the object. So, but then this fourth one, which is location based AR, this is based on a geographical location, the latitude and longitude that you try to locate. So, your GPS, campus, accelerometer, all these are used in locating or giving you an augmented reality experience, especially this Pokemon Go game, wherein you have to keep changing your location, and based on the change in your location, a certain Pokemon will appear. Ingress, Wikitude. If you may not have experience, you can check these. Based on the change in your latitude and longitude, a virtual object or a virtual Pokemon used to appear. So these are all types of tracking based on the Hikum, who has created this three.js library, the creator of this library. He talks about it, but we want to talk about the technology for today, which is our face filters, which is built on top of the neural network, your face detection neural network, combining the power of deep learning, the different deep learning models with your web graphics engine model and the three.js library. So we will quickly do a very, very interesting code snippet exercise also on three.js to understand how does it render a 3D object in a 2D space. And also it uses a simultaneous localization and mapping algorithm. When we talk about these face filters are requiring a continuous sensing, continuous locating of different components of your face, your eyes, your nose. When I am moving, the filter should be able to locate my nose, my eyes, and my hair. And only based on that simultaneous localizing and mapping, your face filters are built. And also this relies on the computing power and the 3D scanning capabilities. If you talk about the different video conferencing calls that you do, you beautify and you put up a certain background, the filters, all these are your face filter based or the same concepts based on 3.js library, your 3.javascript library based on JavaScript. So let's talk a bit of the 3.js, what this is. And even before we get into a little detail of this, I would like you to visit this website a bit in detail, and we'll also do a quick exercise now. So let's just say 3.js in Google and go ahead and check out this 3D library. So if you see the entire documentation, everything is provided. It's all open source library. But then you see there are different games. There are different testing applications that are built. A number from Ghost Virtual Worlds of for listening to music. This is something on music. Maybe I'll just stop it for now. You can yourself experiment many other such that had music along with the video that I was showing, powerful motion design in the browser. All this is happening and being rendered by Chrome. If you say the JavaScript animation library, so looks like these are the concepts. We can check out the Museum of Annoying Experiences, the index. So just trying to showcase you the power of this interesting library. So there's a lot of buzz around AI or artificial intelligence, but there is so much more around augmented reality as well. This has helped people market a lot. So it's saying this presentation journey to a more primitive time when bad customer service was common and most interactions were incredibly annoying. Okay, you have been warned. Let's say enter, drag to move. Yeah, I mean, then you can just play around. There's sound as well, there's music. I mean, this is what the graphical power of this is. But then my suggestion would be that depending on your requirement, just check out what are the different experiences available. For now, I want you to go and say yes to this kit development. The moment you say yes, let it run. I hope the kit is installed for you as well. So this takes a little bit of time since it has amazing multiple demos. So once this runs, you will see that it will give you a link to run onto your local systems. Once it will be able to run completely, it will give you three different links. Just copy paste one of these, paste it into your browser. Okay. Hmm. We'll just check what made it stop. Let's pick any one of these, paste it in our browser, and just say advanced, proceed. This is on your local system, so you don't need to worry. Click on the demos, get into three.js. We are talking about this three.js library here today. Let us go with the tiger one, and we would want to say allow. And this is the experience of the filter. When we move in and out, so this placement, correct placement, and on opening the mouth, the particles coming out and closing it. It should. This is what we are trying to build today as one of the examples. There are multiple such examples. Let me show you more. Maybe this one. This is some angel demon one. So this is an angel. This is a demon. Say ooh. Oh. The angel is hitting the demon. And then yes, a bit more of things you can do here. Let me help you check this one as well. This is from your money heist. This also has the music. You can go for dog face, which is very common filter, right? So placement has to be correctly done at the different positions. So yeah, there are multiple such present here. You may check out any of these. There's many more. There's an anonymous one and much more. So this is the folder. You have to go ahead and understand. Apart from this, once you set the kit, this is the folder that you should right click and open in VS Code or any editor that you are comfortable with. Correct? And as you open, you saw that we went into demos, we went into three.js, and I'll choose the Tiger one, which has this main.js as the file as well as index.html. This is we discuss details of all of this. I also quickly want you to get back and discuss a bit more going ahead. Let's discuss a little bit more going ahead. We want to talk a bit about this three.js library. We said that it is a helping us. It's an open source library, so which is the best thing. All of us can use it for free of cost. It's based on JavaScript, and the 3D engine is pretty lightweight. You saw that amazing graphics we were able to render on the browser itself. It uses WebGL, and that's how it draws the 3D models. So I'll also showcase you quickly about Blender that is used to create 3D models. That 3D face, that virtual face that was appearing, that tiger face that was appearing on my face, we have to create one of that kind as well, right? So you can learn how you can create these 3D models using Blender or different other similar tools that are available. 3GS allows you to use your GPU to render the graphics in 3D. So your graphics processing unit is used. And how does it do? All that is being rendered on a canvas. Okay. We'll see that we'll create a canvas in the we have a canvas, right? And within that of your web browser is where the rendering will happen. You do not require any third party plugin to run the code. So that is the most interesting and efficient thing about three.js. How do you do the rendering? I mean, so very important three things to note. You need to create a scene, the environment. Think of yourself as a director, and you create a scene, you have a camera object, and then you have a renderer object. Three things. One, the scene in which you want to showcase something. Let's say a person, and that person is your object. And then there is a camera through which you are capturing that object. Okay, three simple things. But when we are talking about creating these different 3D elements, right? Putting that 3D face onto an object like me, the important thing is that you create the renderer object, the 2D object, which can be provided and put clearly within the space, and the camera should be able to capture it. So how do we do the capturing of the camera? The interesting fact here is you do not move, you do not move the camera much. You can entirely move the scene here for the camera. So that is how the interesting rendering of 3D elements happen in case of your three.js. So very important, we want to display anything, you need three things. First, create a scene, create a camera object, and then create a renderer object. Three things, okay? And once you have all these, you represent the 3D objects using a mesh. What is this mesh? Which is composed of the geometry and material that is being used. Okay. What shape it will have? Geometry is basically whatever shape, say it's a spherical shape or it's a square shape, cube shape, all that is being defined. So there are too much details to it. We won't worry about the detailing part, but we'll talk a little on the tool that is Blender that is used to create these 3D models. So the 3D graphics application, which is under the general public license, is this Blender, and it converts your 3D model to JSON format, which makes it super low sized and highly efficient to be able to render. You see, there is a lot of graphical interface that is being attached. So the lightweight the file is, the easier it is to project or easier it is to render onto a certain uh, real object. So Blender's comprehensive array of modeling tools, they help you create, transform, edit, all of that can be done. So let me quickly also show you. First, we'll talk about the importance of open source. This is something that I keep vouching for. Everything is free of cost, everything is available to you. You say you have great security quality, but remember to always check the license of the thing that you're working with. Permissive license is something which is very essential. If you don't have a permissive license, then there are chances that the component, or I would say something that you may use for your product, uh, may be encountering, or maybe something that will have you you need to pay prices for it if you are using it without the knowledge of the license, even when you're working with an open source tool. So always check what license it is under, and then start using an open source tool. So where do I check this license? Do I have to check each and everything? So go on to kandi.openview.com. All this listing for each library repository is already done for you. I Let me show you step by step. Let's try and check how Candy will help. Let me first take you to our live bootcamp page. Here you have an option to visit this kandi.openview.com, and this not only tells about those four features that I said. Let's say I write three.js. Okay, I search for this library. I will start getting I will start getting the code for it, different code snippets for it, which I can work around with. And if I click on the libraries, if I specifically want to talk about a library which is based on three.js or a project, then you can say sport security license. All of this is mentioned. You can just click here, get into the details, check the stars repo. You can see the license. It's an MLT license. The license is permissive. Any license which is permissive is free to use without any restrictions. So that is very much important when you are trying to build your own project. So you can check out these. Apart from this, a very interesting thing that you can do is you go to this page. Again, we have given you an option to click on this code snippet option and actually do a exercise. You can actually do an exercise of three.js. We have also listed down the link here for you. Supposedly, you want to do an exercise in three.js. So let's say, how do you set up a scene? Basic three.js scene setup, if you would like to do. Just click here. This link will give you the code snippets, not only just one, but multiple code snippets. Let's see, let's say we want to check out this particular code. We copy this code snippet, and then I told you about the IDE that we had, right? Get into this IDE where wherein I'll create a folder. Okay. How do I work around this? We have also listed down the steps for you, but just follow alongside with me. What I want to do when I want to create this basic scene setup in three.js, how do I do it? Just say new folder. Let's say I'm creating a new folder in demos. I'll say code snippet. Within this new folder, now I have to follow this set of steps. One important thing to note when you are working or creating something for the three.js as well, to be able to develop and check out your code that I'm currently talking about, you need to have Node.js. So most of the dependencies we already installed. Just in case you want to check, just check it whether you have Node.js installed or not. Go into your add or remove programs. And we'll make a quick search for Node. So Node is there, which is great. While I was trying to set up the other things, what next you would like to do? You need an IDE, right? So let's say you may be using some other IDE, but we are using VS Code, a standard IDE for web development, and helps you with work with Python and many other programming languages. What I did was I created a new folder, and then I will open a terminal within that folder. Within the same folder, I'll go ahead and say terminal and new terminal. Let the path appear. This is currently present in jealous main. I'll say cd code tab. Okay. I hope, yeah, it's in demos. So I'll go for cd demos. And within cd demos, it is code snippet. I'll get into this folder, okay? A new folder that I have created. Next step is after we have created this new folder, I want to create an application. So for that, the command is npx create React app and the name of the file. So I'll just copy this, and to be able to create my own file, let me give the file name as my file dot, since we are creating a JavaScript file, say .js. This will start creating this file within this particular folder. So we'll just wait for this to create an app here. Okay. Once this gets created, let this get created. In the meanwhile, I would like to show you how you can work around the same steps. If you think where are the steps listed, go and click on this code snippet kit. The instructions that you would like to follow are all listed down here, step by step. But I'm also doing these alongside with you. Important thing to note is you should have these. Next step, create a new folder wherever you like. Then I have created a React file. This takes a little bit of time. Then I'll get into this file. So this is getting created. We'll wait for the completion to happen. And as this file is getting created, I will actually utilize time that is present by explaining you the code for our tiger head or the virtual tiger that we had created. If you get into this folder, you have index.html, that is one of the essential files. We have listing for different dependencies. This is standard three.js. We have used tween, we have used three, we have face filter. There are different helpers here as well. Some basic complex code. You just don't have to worry about the complexity. Just will try to understand step by step what is happening. First of all, we have some 5 to 6 variables for the camera, the mouth opening, particles, the tiger mesh mouth, and we also have a variable for detecting the mouth open or close. So for that, this function is there. We log on whether the function is able to detect mouth open or not. Further, this function generate sprite. This is for the different particles, small particles that were coming out, right? So we draw these on the canvas and define the width and height of the canvas, which is 16 by 16, and then try to get a content, which is your 2D content. So what is this 2D content? Let me showcase you that as well. Within this blender, within this blender, this is your blender, and I'm just saying open one of the files for me. So this is a little heavy application itself, where we draw your 3D models. Where we draw the 3D models. We are just trying to, yeah. So here is your tiger face. This is the face that is being created. This looks a little complex, but then there are free tutorials as to what are the different. This is a default view that you would get. So you can go ahead and go for material, eyes, the face, torso, correct, and then the right and the left orthogonal, everything you can check in the preview, as well as go for different varied views that are available. You can get to the scene. So this is one of the views for motion tracking, though that was a default view. So there are different renderer layers. Okay, there are different renderer layers based on which you see the face gets particularly rendered. So this is a complete separate thing. You may have these 3D objects already created and you start working with these. Okay, so one thing is that we'll come back to our discussion of what is happening with the tiger face. So with the tiger face, we see that there are some color stops, which is ranging from black, which is in the range of black to white, and then this is the fill style. So we are filling the style of the particle. Okay, what color fill it will have, and then defining the width at which it will on the canvas showcase. Then we are defining an init particle, one particle visibility, doing some maths exactly where it should be placed, how it should be, what position it should have, what visibility it should have. Check these three parameters: particle, delay, direction. Okay, we are mentioning what is the delay in the different particles that will move, what is the direction, and the particle itself, the size and everything, the width and everything of the particle. Then you have used tween scale. So then this is another method that is used for the particle, for the scaling and descaling of the particle. Important is your mask material. This is the mask that you are checking upon, wherein just don't worry about all of this math. What you would primarily want to focus is that it clearly looks at the length vectors here, the fading and opening and closing of the eyes, how that has been matched. Your uh, vector value is being initialized like that. Your then alpha mask equal to smooth. Again, one is for left eye and the other one is for right eye, so this will be right eye, this is an error here. Then the nose is opaque. The nose looks exactly, it's an opaque feature. After that, I guess my filter is closed for now, but yeah, this is the main function. This is where we are trying to sample all these different functions. We draw so many different functions for particle, for the face, for how the particles will move in and out. So then here you have your three dot shader material, within which you will assign the object, work around with the 3js mouth opening, etc. This texture is where you are defining the material of the uh, those, what we should say, the 3js has is loading the texture material of the particles. Then three scene is where you are now saying that this is okay, and now you want to check further. How is, see, we said there is geometry, we defined the position, delay, and the width, etc. Then there comes your the entire mesh, which contains both the material and the geometry. So here is where we are defining the material. Then this tigerhead.json is the file that we have loaded from Blender. Okay, this is that file that we have loaded from Blender, and this is how we set it to scale and to position. uh, so this is something that will depend the on the filter that you're working around with. And then you have the same the same set for your filters. I mean, how do you build the particles, how do you call the generate sprite function that we defined up further. If you keep checking the code, what was important, the light is something that is essential, the camera is something we create. And then after we have created this is the main function, where your canvas and all the callback happens with the console. You are able to render that particular, once it is detected, you are able to run or place that clearly onto the face. So if detected, let mouth opening is detected as open, then they will showcase those particles. And if it is not open, then it will showcase it as like the particles won't come out. So or that scaling, there's too much to this. So suggestion would be not to focus on the entire mathematics of it. Just remember to create a very simple code. So I was thinking to help you work around with the simple code. I created a folder called code snippet, and within the code snippet, let me get back to the terminal. Within the code snippet, next step would be after I have created, um, okay, what we created a file app.js is the file. Hmm. So we'll just check within this jellies, demos, code snippet. My file.js is what is already placed here. So let us get into cd my file. Okay. Within my file, what is the next step that I would like to do? Now you have to install the i3. Okay, i3. So just copy this command, paste it here, and let this also get set up. As this is getting installed here, we will remove this entire code that is present in app.js. Okay, just say Control A, delete, and copy paste the snippet that is available here. Just say copy, paste it here, and then we'll see for what is missing. As this is getting worked upon, we also have to make an import for the library three.js. So I'll copy this, paste it here, and apart from this, we also have to add an instruction for exporting the animate function. So I will say export default animate. I'll add that as well. So in the meanwhile, my last instruction ran on the terminal. I was able to edit this file where I just added the instructions that were not there. This import for three file. I just installed the three file. You saw npm i3 to install it, and added an instruction here at the last for exporting this animate. After we have done this, next step is to just start this file using npm start to run it. So we will just say on the shell on the terminal, I'll save this, and then I'll say npm start. So this will actually create this 3D model. Let's say yes, it's running. So I'll say yes, and we'll wait for it. It will run onto your local machines only, but it will take a little bit of time because it is using the graphics of your browser, graphic engine, WebGL engine of your browser to showcase a 3D graphic. We'll just wait for it to load. And this is a 3D model that we just quickly created. A very simple code by searching. What did we make a search for? Basic three.js scene setup. Okay. So we said that a scene will consist of a camera, an object, and a renderer. So let's get back. Check here. What did we simply do? We made an import for the three.js library. We defined the scene, camera, and renderer. Also, we had important part for geometry, material, and mesh. We initialized and called the animate function. In the init function, I have defined my scene. The scene also defines my camera, the width, height, etc., the position of my camera. Then comes your geometry, wherein we are defining a box geometry. It's like equal to 200 box geometry and a basic mesh material. So this is the color that has been defined, and the wireframe is set to true. Then I've just mentioned the mesh here, and I've added this mesh to the scene. And use and now the camera is set, the geometry is set, the mesh is there. We need the renderer. So we just call new 3.webgl renderer so that the browser is able to capture it and set the size So with the inner width and inner height, or within the window only, it is able to capture this form. And then we just appended this as a DOM element here. So this animate is what is able to showcase the rotation, mesh rotation in the x and the y axis as well. And the rendering happens of the scene alongside with the camera here. So this is something that you may go ahead and learn a bit in detail. But then this was the simplest of the code that we could demo as of now. And it is also available for you on the community platform. Okay, so I see that there is an error. Okay, so for your error, Abdul, that where you are mentioning the address already in use, that means your local host is already being opened and is being used. So if that is the case, for it being already used, can you also elaborate a little bit that did this happen after you opened one of the instances or multiple instances on your laptop? This means the kit already got set up and you had copy pasted the URL. I hope I'm understanding correctly here. Okay, we'll wait for you to comment back. Coming back to what I was talking about, this is a little niche area, so you may feel that this is a bit, something that takes time. Don't worry about it. Try following this up step by step. When I say step by step, go with this first scene setup. Try and see if you're able to run the basic code. And only when you're able to run this basic code, you should be able to go ahead and understand a bit about this 3D graph using three.js. We have listed down the instructions clearly in the code snippet kit, which we have provided at the bottom. So you can see, you can directly copy paste the code, read the instructions and follow from here. And if you still face issues, post it by logging in onto the community. It's important that you log in to the community. Without logging in, you'll see that once you log in, you will have this chat feature activated. You will have this reply button activated so that you can uh, ask your queries directly over this platform. So I hope we were able to give you a good refresher of sorts of this interesting face filter WebGL based, 3JS and WebGL library. And I tried to cover three very important things in today's session. A basic of augmented reality, what it is, try to compare it with VR and metaverse. We did a hands-on session to build our own face filters with the three.js library. And then we also saw that how you can use kandi to directly build one of your own such application without installing each and everything from scratch. So for our participants today, I would suggest that you can have a look at many of such kits, not just this kit, but we have many other kits which are developed by young and senior developers on topics that are relevant in today's world. You saw one on face filters, but then there are more on augmented reality as well as AI, blockchain that you can explore going ahead. Also, you can participate in many more sessions, and I hope you enjoyed what we tried to present within this 1 hour duration that we have. Uh, I'll just take the comment what Abdul has mentioned to follow along you, and this happened. Okay, so extract the folder before installing this batch file. After you install it correctly, the address shouldn't, this error shouldn't appear for you. This is happening because it is not able to open your file onto the server. Also, another thing to note is that as we discussed about this face filters kit, you may want to try some other interesting concepts. So, after you have answered some polling questions here, you see that there is an option to also get open source enthusiast badge, for which again you just have to check out the kit, build any of the filters. I mean, just check out the different filters and let us know which one was the one that interested you the most. Also, on the community, you have an option to check for other learning hubs for programming, gaming, AR, VR, blockchain, big data analysis. Go ahead and explore these as well. Within the live sessions, you have the bootcamp page where there is an option to apply for certification for the session that you just attended. You'll get a participation certificate if you answer the two questions which are there on the. You just have to click on the take assessment. Go ahead and answer these questions. And once you answer these questions, five questions, you will be able to go ahead and submit for certifications here. So there is an option to get an achievement certificate by showcasing the filter that you used and also sending us a screenshot or photo video of the filter that you added to that you liked and that you tried to experiment with. You can even add a simple image in place of the filters that are already there. Maybe change the background or something if you can at all. So to be able to get ahead in the journey as of now, my suggestion would be that you may have to get a little bit gist of what we already discussed, but then a little detailing for you would help you get ahead in augmented reality. So I hope the session was interesting and you found the use case presented valuable. We will be conducting many such bootcamps frequently and regularly. So if you would like to stay updated with our program calendar, please join our community on community.openbeaver.com, and also follow us on our social media channels to stay updated on information and trends in the world of open source. Thank you.